Let's take a few minutes to remind ourselves how to find the area of quadrilaterals and regular polygons. So you know how to find the area of a rectangle or square and do length times width. A parallelogram is base times height. And what's important is that my base and height are perpendicular to each other. So in this first problem, my base I'm going to use as 18 times a height of 12, which is 216. The way they can make parallelograms more complicated is on the right and make us use either special right triangles or trig. So the trick for this one, I have my base, which is 14, but I also need to get my height, which is what I don't know. And as you see, we have a 60-degree angle, which makes me think I'm probably going to be doing something to do with special right triangles because they never go away, so it's good to learn them. Alright, so if this is 30 degrees, my rule for a 30, 60, 90 is if I have my hypotenuse, then what's opposite my 30 degrees is going to be half that. So then this little guy down here is 4, and then I multiply by root 3 to get what's opposite my 60-degree angle. So this is going to be a height of 4 square root 3. So 14 times 4, which is 56 square root 3. Don't lose your square root. I have people losing square roots. Once again, that's coming from x root 3 to x, and the fact they gave me what was opposite to x. So 8, 4 root 3. Okay, if you still need to be making a little table. So that was parallelograms. Then we looked at rhombi and kites, and for these it was 1/2 diagonal 1 times diagonal 2. So, and it's the same for both. So in my rhombus, I have one diagonal has a piece of 3, so then this other piece is 3. So I have 1/2 times 3 plus 3 is 6, but I need the length of the other diagonal. A rhombus, these make a right triangle, so I can do Pythagorean Theorem, or see that, look, I gave you a 3, 4, 5 triangle. Yay! A squared plus b squared equals c squared. So then my other length is 8, and that means when I multiply those, I get 24. For the kite, they already gave me all of my diagonals, so it's just a matter of plugging them in. So my first diagonal has a length of 13. My other diagonal has a length of 6. So that's going to multiply and give me an area of 39. We also looked at trapezoids. The formula for a trapezoid is 1/2 height times base 1 plus base 2. Alright, so 1/2, my height is 5, and then I have b1 plus b2, so that would be 3 plus 6, which is 9 times 5 is 45 over 2, or 22.5, whichever. But like with the parallelograms, we can do something similar with trapezoids. So in this one, let's look and see what we have. I have my b1 and my b2, so 1/2 height times 11 plus 15, but I need my height. So we have this little right triangle again. It has 60 degrees again, so I can do special right triangles. So 8, which means short leg, is 4, which means long leg is 4 square root of 3 again. Notice these numbers come up a lot because otherwise they get kind of large really fast. So that's going to be 2 root 3, half of 4, times 26. So 52 square root 3. We want everything to be exact. Now, what if they didn't give me 30, 60, 90, or 45, 45, 90? I would need to be doing trig, sine, cosine, tangent, etc. And hypothetically, while we could do that here, we aren't going to get an exact answer. We would have to get a decimal, which is why special right triangles are happy. All right, now let's look at some regular figures. So a regular figure just means all of the sides are equal. So I have an equilateral triangle. I gave you two, actually, because there's two different situations here. Can you look and see what the difference between the first and second problem? Okay, one has a square root 3 and one doesn't. When I don't have a square root, that's where I want to use my normal 1/2 base times height. When I do have a square root 3, it's going to be much happier if I use 1/2 perimeter times apothem. Okay, let's see what happens when I do this. So in my first one, I'm telling you, let's do 1/2 base times height. So I have my base is 10, so 1/2 base, and I need my height. This blue line is what I need. And what I want to use is the fact that in an equilateral triangle, all my angles are 60 degrees. Okay? And we already said our side is 10. So this becomes the exact same problem we've now done 3 times in this video. Okay, there's my right triangle. If my hypotenuse is 10, my short leg is 5, and my side opposite the 60 degrees is 5 square root 3. So half of 10 is 5, times 5 is 25, so 25 square root of 3. Versus looking at 1/2 perimeter times apothem. Could I use the same strategy here? Yes. Are you probably going to cry a little bit? Yes. And same thing goes for the other one. I could use perimeter apothem. It's just you get in craziness with the square roots. So for this one, the first thing I need is perimeter. So I have 3 sides of 12 root 3, so that's going to be 36 square root 3 times I need my apothem. The apothem goes from the middle of a side to the center of the circle. And when I do that, it makes a 30, 60, 90 triangle where the 30 is what's on the bottom. So I'm going to split the 12 in half, which gives me 6 square root 3. And that's opposite my 60, so opposite my 30 is going to be just 6. Once again, if you still need my table, x root 3, 2x. Here we're saying that the opposite 60 is 6 root 3, which means that x, or opposite 30 degrees, is 6. So then, when we multiply all of that, we get 108 square root 3. Finally, for a hexagon, we're going to do 1/2 perimeter times apothem as well. So 1/2, I'm given a side length of 6, so my perimeter is 6 times 6, which is 36, and I need to find my apothem. So if the whole side is 6, then half of it is 3. And what we need to know for these, this is a 60-degree angle, because the full angle is 120. So then I'm going to take that side and multiply it by square root 3. So my apothem is 3 square root 3. And that's going to give me 54 square root of 3.